Today, boys and girls, before we get started, I want you to watch a video, one of my ones that I sing often. It's prime, P-R-I-M-E. Prime numbers are something we're going to be using for our lesson.
Prime, 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 prime. I'm prime, P-R-I-M-E. Only factors are 1 and me. Factors that divide evenly. 2, 3, 5, 7, 11. Woo! I'm prime, P-R-I-M-E. Only factors are 1 and me. Factors that divide evenly. 13, 17, 19, 23, 29. Yeah! I'm prime, P-R-I-M-E. Only factors are 1 and me. Factors that divide evenly. 31, 37, 41, 43, 47. I'm prime, P-R-I-M-E. Only factors are 1 and me. Factors that divide evenly. 53, 59, 61, 67, 71. Hey, I'm prime, P-R-I-M-E. Only factors are 1 and me. Factors that divide evenly. 73, 79, 83, 89, 97. Yeah, representing prime 1 to 100. Let's go. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, and 97. Yeah, prime numbers, prime numbers.
Today, we're going to take a look at Getting Ready for 6th Grade, Lesson 3 and 4. The first one is Lesson 3. Our essential question is, how can you factor numbers using a factor tree? And so our I can statement is, I can find the factors of a number using a factor tree. So before you can use a factor tree, we also need to know something about some numbers. So take a look at the problem of the day, and then we'll talk about how that actually relates to our factor trees. Anna bought 28 jelly beans. Which statement is incorrect? She can divide the beans equally into groups of 7. She can divide the beans equally into 3 groups. She can divide the beans equally into groups of 4. Or she can divide the beans equally into 2 groups. So take a minute and think about what you think. But if we take a look at division, let me get my pen tool. And we take 28 and divide it by 7. We can see that 28 divided by 7 is 4. And if I do 28 divided by 3, that would be 9 with a remainder of 1. And 28 can be divided by 4 because that's 7, and 28 can be divided by 2, and that would be 14. So the correct answer for this one is, the one that is incorrect is she can divide it into groups of 3 because she will have a remainder. So when we're factoring down, we're looking at the 2 numbers that will make up a number that we are looking for. So we're going to break down numbers into their factors, or what we can multiply them by. So when you take a look, we have greatest common factors. So those are the 2 biggest ones that I could multiply and get those numbers for. So how do I get 8? I can get 8. Oh, I just had that writing for me over there. I can get 8 by doing 2 times 4, and we can also do 1 times 8. We're not going to use the 1 factor, but I am going to write it down here so that we have the 8. And what are the ways that I can make 30? I can make 30 by doing 1 times 30. I can make 30 by doing 2 times 15. I can make 30 by doing 3 times 10. Sorry for the messy handwriting because I'm using my mouse. I can make 30 doing 4. Nope. But I can do it 5 times 6. And that's the end. Now they want to know the biggest one that matches. So my biggest one that matches here looks like it's going to be 2. And that is what a greatest common factor is. So if I'm looking here at 40 and 24, thinking through, I've got 1 times 40, and I know 40 can't make 24. I've got 2 times 20, and I know 2 can make that, but 20 can't. Then I can do 3. Nope, I can't do 3. I can do 4 times 10, and I know 4 times 6, so far 4 is my biggest. I can do 5 times 8. Oh, 8. And I also know 8 times 3 makes 24. So 8 is my biggest factor here. Thinking through my 10s, I've got 1 times 10, which 10 doesn't make 8. 2 times 5, and 2 does work. And that would be the only factor that would match for those two. And when I look at 6, I'm thinking here again that the only one that would probably work is 2, because I've got 1 times 6, and 6 can't make 20. And then I have 2 times 3 for 6. So the greatest common factor, once again, we're breaking down those numbers into the smaller pieces. I'm going to give the video a quick pause here and see if I can get this pen to work a little better.
Lesson of the day was making factor trees. There's just one thing, factors are prime. What are primes? They're a special type of numbers. Only factors are one in itself. Factor down a tree. Lesson seems strange to me. Never would come to me. Break down the number, please. Factor down a tree. Number 9, branch it down with primes. You get 3 times 3, they also prime. 3 times 3, circle them for me. Yeah, I can see a factor tree. Number down for me. Branch it out in 2s and 3s. Circle all the primes for me. Factor down a tree. Circle all the primes for me. Factor down the tree. You can simplify, give powers a try. You can square a cube, all like primes. 24, branch is 6 times 4. Now it's 3 times 2, 2 times 2. Tree. Break the number down for me. Branch it out in 2s and 3s. Circle all the primes for me. Factor down a tree.
for us. For that Mrs. Wells commercial break, you also got to watch that video on Factor Down the Tree. Let's take a look at this question. Mr. Shu gives his puzzle to his math students. Write 24 as a product of factors that are prime. P-R-I-M-E. The only factors are 1 and me. I'm prime. Remember that prime numbers must be greater than 1 and can only have 1 as its factor. And you can use a diagram called a tree factor to find the factors of a number. So factor trees are only going to use prime numbers when we get to the bottom of the level. So it says, give an example of a number greater than 1 that has only 1 of itself. So we're looking for prime numbers here. So the first prime number I know of is 2. And then 3 does, because it's only 3 times 1. But 4 does not work. 2 is really the only even number that does work. But 5 would work. 6 doesn't, because I have 1 times 6 and 2 times 3. So there's 2 different sets of factors. And then 7 does work. 8 doesn't. 9 does not, even though it's odd, because we have 1 times 9. And then we have 3 times 3. So that's 2 sets of factors. So we're only looking for 1. 10 is even, so we know that doesn't, because 2 times 5 is 10. 11 is a prime number. 12 is not, and 13 is a prime number. Keep going here. 14's not, and 15 isn't. There's that odd number. So we can automatically know that we're not going to write any even numbers except for 2, but we have to really look at those odd numbers. So 15 doesn't work because we have 1 times 15 and 3 times 5. So we're going to take a look, and they're going step by step as we go here. And it says, write the number to be factored at the top. So we're looking at the number 24. And so we need to think of 2 numbers. Now they gave you here 4 times 6. You could even start with 3 times 8. It doesn't matter. But then we're going to break down 4 times 6 because 4 can be broken down even more. Now remember, we're never going to write down anything with a 1 because 1 is not a prime number. So we're only looking for prime numbers. So 4 we can break down as 2 times 2. And then down here we can break down 6 like 2 times 3. If you're really struggling with this, you need to get a multiplication chart to kind of help you. And then we're going to write all of the numbers in a line. 2 times 2 times 2, or 2 times 2 times 2 times 3 does equal 24, because 2 times 2 is 4, 4 times 2 is 8, and 8 times 3 is 24. So we're going to write 2 times 2 times 2 times 3. Now one other way you can write this, which I think is really cool, there's 3 2's there. So I can put 2 exponent 3 times 3. And that's 2 times 2 times 2, because remember it's all about the base times the base times the base. So it's 2 times 2 times 2, then times 3. So is the product, the factor, the same as the example? So it says make a different factor tree. So let's start with, so you can think of either 2 times 12 would work or 3 times 8. Since 3 is my favorite number, I'm going to start with 3 times 8. Now, this is going to be a lopsided tree, one that wouldn't stand up very well if we cut it down for a Christmas. But here we go. We can break down 8 into 2 times 4. And once we got this one already broken down, we only put 1 line to it to try and keep my tree a little balanced. And now 2 cannot be broken down. But this is a 4, even though my pen didn't look like it, and I can break this down as 2 and 2. So looking at the bottom here, I have 3 2's and a 3. So is that the same as the others? So is the product? Yes. The prime numbers, I'm going to go to typing for this. Yes. Not quite sure what happened there, so we'll make sure that we're back on here. Yes, the prime numbers are the, I type it seems to reset my my recording here, but I noticed that cut me off there at the end, so I came back on to make sure that you got the final answer here. I worked backwards using the smallest odd prime number, 3. So I did look, it is chapter 1, lesson 2, so 1.2 for getting ready for 6th grade that you need to be completing. Bye-bye. I worked backwards. Use